Hey everyone, I'm Lucas, and this is going to be my recorded walkthrough of my practice test for Concept Check 1 functions version A. This is only going to be version A. Versions B and C are there for extra practice. Their answer keys are also posted. So, my goal with these recorded lessons is I'm going to break down the exact logic you need for each problem, like go through my line of reasoning and look at why the wrong answer choices are wrong. Because I put a few traps on here. If you've already done the practice test, you might have seen some of those. And also, I'm going to address some common misconceptions that I see a lot of students make where they lose marks on these types of problems. So let's get started with problem one. Does the graph of f of x represent a function? Justify your answer. Before we start, I think it's important to establish some vocabulary that'll help us answer this question with the preferred advanced algebra 2 language. So let's start with our x values. Our x values, we can call them many different things. We could call them the inputs, we could call them the independent variables, but more importantly, we can address them as the domain. Domain is referring to the set of all x values that are defined for a function. And I use domain on my answer key because it's a word that'll come up a lot in this course. So I'm getting you kind of familiar with what that word actually means. Conversely, if we're talking about the y values, those are what we would call the outputs or the dependent variables, aka the range. Again, I'm going to use range on my answer key because it is a word that'll come up a lot in advanced algebra 2. So just really get familiar with that type of language. Now, using any of these vocabulary words, what is your definition of a function? I want you to answer that in your own words. And the way I would define a function is when each element of the domain is mapped to exactly one unique element of a range. And in simple terms, what that really means is that for every x value in a function, it produces exactly one y value, no more than 1. Okay, using that definition, however you defined it, let's look at our graph of f of x right here. If we choose any x value between that where the function is defined, like let's say I pick the point right here. If we draw a vertical line through that point, we can see that it intersects the graph at 4 distinct points. So for the singular x value right here, it produces 4 outputs. Now this is not a function because, like we said, every input needs to have exactly one output. But as you can see here, the singular input of x produces 4 outputs. So therefore, f of x is not a function because there are elements of the domain that produce more than one element of the range. So that's kind of that justification part of your answer. And in Algebra 1, you probably would have just said this is not a function because it fails the vertical line test, but we're in Advanced Algebra 2, so we really want to start using this vocabulary right here. Okay, question 2. Which of the following equations represents y as a function of x? And I think the best way to start learning these kind of problems is to just solve for y. Just isolate y in every equation. We have a y squared here, absolute value of y squared. And because if we do that, we get to see if y equals just one clear expression. If solving for y forces a split path or like multiple answers, it is not a function. And you'll see that occur with 4 of these answer choices. So let's start with A on the left. X squared plus y squared is equal to 49. To get y by itself, we're going to subtract x squared from both sides. So y squared is equal to 49 minus x squared. And now, last step to isolate y, we're going to take the square root of both sides. And this is a very critical algebraic rule. It also came up on your summer work. When we're taking the square root in an equation when solving for a variable, we always need to add a plus or minus in front of the square root. Because when we square a number, it doesn't matter if it's positive or negative, it's still going to produce a positive value. that is seen with quadratic functions, which you'll explore a little later in this unit. But as we can see here, solving for y, it gives us a positive and a negative version of this expression. So if we were to plug in a valid input x, that would yield two outputs, a positive and a negative version. Therefore, a is not a function because if you plug in an x, you would get two outputs. This is actually the equation of a circle. If you were to graph this in Desmos, you would see that it is, in fact, a circle. Additionally, answer choice B, x plus the absolute value of y is equal to 12. To solve for y, we need to subtract x from both sides. Absolute value of y is equal to 12 minus x. And now, thinking about absolute value, what is absolute value? Well, absolute value is the distance from 0. So for example, if we have the absolute value 5, that's going to be equal to 5 because 5 is 5 units away from 0. Now let's take the absolute value of negative 5. What is that equal to? Well, it would also be equal to 5 because negative 5 is 5 units away from 0. We can kind of think about that on a number line. If we're at 0 and we're over here at 5, and then we're also at negative 5, this distance here is equivalent to this distance there. So that's why absolute value always produces a positive output, because it's just referring to distance. And you'll learn that a little later as well. That's just kind of an introduction. So using that kind of concept, we could say that y is either the positive or negative version of this expression, right? Because it's just referring to distance. So therefore, y is equal to plus or minus, and then parentheses 12 minus x. We need to use parentheses because we're referring to this whole expression, not just 12. You wouldn't say y is equal to plus or minus 12 minus x. So that plus or minus is just on the 12. Just keep that in mind, that you always want to include parentheses in cases like that. And just like with a, plus or minus is going to invalidate b as a function. Now with c, we're not even going to show even any work here. Y is equal to plus or minus the square root of x plus 5. Right here, we already isolated y, and we have this plus or minus for single input. It's going to yield two outputs. We can automatically eliminate c. I'm going to come back to answer choice D. Let's just focus on E last. So y squared is equal to x minus 3. Our only step in isolating y is to take the square root. So therefore, y is equal to plus or minus the square root of x minus 3. And just like a, b, and c, we have that plus or minus. E is not a function. Okay, now lastly for answer choice D, x squared minus y is equal to 15. To isolate y, we're going to subtract x squared from both sides. So negative y is equal to negative x squared plus 15. You could have also written that as 15 minus x squared. Same exact thing. I'm just going to put it x squared first, which I'll explain in a second. Now, if negative 1 is multiplying to y, we're going to have to divide by negative 1 to eliminate this. So dividing everything by negative 1 is just going to flip all of the signs from either positive to negative or negative to positive. So therefore, y is equal to x squared minus 15. And now what we can see is that we don't have a plus or minus, right? All of these other answer choices have a plus or minus, but y is just yielding one. Well, for a single input, we're going to produce exactly one output, right? There's no plus or minus, therefore D, in fact, is a function. So that would be your correct answer. Additionally, this is a quadratic function because we are dealing with an x squared term. This quadratic function is shifted down 15 units. If you don't understand that quite yet, you'll learn that a little later on assignment 3. And that is why this is a function. Now, for a little shortcut for these problems, you could have answered this problem in 5 seconds. I'm going to show you how. So what we can notice from these plus or minuses is that anywhere in the equation, if we have a y squared or an absolute value of y, we can automatically eliminate it as not a function, right? Y squared produces plus or minus. Absolute value produces plus or minus in equations. So therefore, A, B, and E can automatically be eliminated. Now C, y is not squared, and we're not taking the absolute value of y, but it literally states that we're going to have two outputs for a single input, like I said with the plus or minus. So we could eliminate C, leaving D as our correct answer, right? No plus or minus, y is not squared, we're not taking the absolute value. So that's just a little shortcut you could use for these types of multiple choice problems. Okay, problems 3 and 4 are going to use the functions n of x is equal to 3x minus 1 and g of x is equal to 3 minus 4x plus x squared. And we are asked, where is the problem? I don't know where the problem is. Let me write that real quick. Problem 3, I don't know why it's missing, but problem 3 is g minus n of negative 4. Okay, that is a poor drawn 4. Let me rewrite that. Okay, now this notation could be a little scary to start off with. However, if your brain isn't really processing what this is saying, imagine this is equivalent to g of negative 4 minus n of negative 4. And all this is saying is instead of having g of x right here, we're going to plug in negative 4 for x, right? Negative 4 is our new input. So we're going to plug negative 4 in for every x that we see. And then we're going to subtract that from n of negative 4. You're going to plug in negative 4 for every x in n of x. So let's start with g of negative 4. G of negative 4. We need to plug in negative 4 into g of x. So that's going to be equal to 3 minus 4 times negative 4 plus negative 4 squared. Now, I'm going to go on a little tangent here real quick. Let's say we have a positive number, these are parentheses by the way, a positive number multiplied by a positive number. What is that going to be equal to? A positive or a negative number? That would be a positive number. Now let's say we have a positive times a negative number. What is that equal to? That would be a negative number. And then lastly, a negative times a negative is what? A positive number. So keep this in mind, because the way I reverse engineered this problem is you're going to encounter a lot of scenarios like this where you might mix up positive or negative. So there's a lot of places here where I'll show you where you can mess up your signage. So keep that in mind when going through this problem. Okay, this is going to be equal, well, negative 4 times negative 4. Remember, two negatives make a positive, so that's positive 16. And then negative 4 squared. Ask this to yourself. Is that going to be a positive 16 or a negative 16? That's going to be a positive 16, right? Negative 4 squared can be rewritten as negative 4 times negative 4, which is just what we did over here. Okay. Last step, we're going to add 3 plus 16 plus 16. 16 plus 16 is 32. Right, yeah. Plus 3 is going to be 35. So that's g of negative 4. Now we need to evaluate n of negative 4. So I'm going to do this in a different color. N of negative 4 is going to be equal to, and then we plug in negative 4 into our function, n of x. 3 times negative 4 minus 1. 3 times negative 4 is negative 12. Positive times a negative is a negative. Minus 1. It's going to be equal to negative 13. Okay, now our last step is to actually evaluate what the problem is. Our problem is g minus n of negative 4. So g of negative 4, like we said, was 35. And then we're subtracting, and I'm going to put parentheses here, negative 13. Now, if we're subtracting a negative number, is that going to be positive or negative? That's going to become positive, right? Subtracting a negative will produce a positive number. So 35 plus 13 is going to be 48. That is our final answer for problem number 3. Hopefully 4 is, yep, okay, 4 is actually written down. For problem 4, we're going to use our same functions, but instead we're going to evaluate and simplify n times g of c. Now again, if your brain isn't really comprehending this function notation, we can rewrite this as n of c multiplied by g of c. So what we're really going to do here is we're going to plug in c into both functions, and then we're going to multiply them together. So in this problem, you're not actually going to get a integer, like a number, as your final answer. You'll have a expression. We'll call it a polynomial. So let's evaluate n of c. N of c is going to be equal to 3c minus 1, right? We're just substituting in c for x. And then g of c is going to be equal to 3 minus 4c plus c squared. Where is my c? There it is. And then I'm going to reorder this from the highest power exponent to the lowest because it'll help when we're multiplying, when we're going to combine like terms. I just like writing from highest power to lowest power. So c squared minus 4c plus 3. You don't have to do it that way, but I would say it makes the math a little easier. And you'll see when we start multiplying. Okay, so now that we know what n of c and g of c are, we're going to multiply both of these quantities together. So n times g of c is equal to 3c minus 1 times c squared minus 4c plus 3. And now, to multiply this out completely, we just need to distribute. So let's take the 3c first and multiply it by all three of these terms. 3c times c squared is 3c cubed. 3c times negative 4c is negative 12c squared. And then 3c times 3 is positive 9c. Now we're going to take this negative 1 and distribute it to every term. Negative 1 times c squared is negative c squared. Negative 1 times negative 4c is positive 4c. Then negative 1 times 3 is negative 3. Now we have some like terms that we're going to combine. As we can see here, this negative 12c squared and this negative c squared can combine. And then this 9c and this 4c can combine as well. So our final answer for problem 4 is going to be 3c cubed minus, well, negative 12c squared minus c squared is negative 13c squared. And then 9c plus 4c, positive 13c, and then minus 3. We can't combine. There's no term to combine with the c cubed, 3c cubed, or there's no other number to combine with the negative 3. So that'll be our final answer for problem 4. Okay. Problem 5. A local shelter tracks the weight of a puppy over time. W of t models a puppy's weight in pounds when it is t weeks old. What does the statement W of 12 equals 15 mean? I think it's helpful here to underline literally what we're given. So we're given this function right here, W of t, that we are told models the puppy's weight in pounds. So whatever W of t is equal to, that's just going to be the number of pounds. Okay. And then we're also given that t represents how old the puppy is in terms of weeks. So if we're thinking about W of t, I'm just going to use a question mark. Our input t is how old it is, so weeks old. I'll put number of weeks old. And then our question mark is going to be what is equal to the puppy's weight in pounds. Okay, now we're given an equation right here. What does the statement W of 12 equals 15 mean? Well, we've already defined our variables, right? Our input is how old the puppy is, so the puppy is 12 weeks old, and it's equal to 15, which is the puppy's weight, so 15 pounds. So how we would interpret this in words is when the puppy was 12 weeks old, it weighed 15 pounds. And that's going to perfectly correspond with answer choice C. And now, well, why are A and B wrong? So let's look at answer choices A and B. C is the right answer, but it's also good to understand why those are incorrect. For choice A, it says, when the puppy weighed 12 pounds, it was 15 weeks old. Well, this completely flips what we're given. It's saying that the weeks old is what is the output, it's what we're equal to, and that the weight is the input. But that was not what we were given, right? We're given that the whole function is equal to the pounds, and that the input is how old the puppy is in terms of weeks. Okay, now for answer choice B. It says the puppy grew 15 pounds over the span of 12 weeks. Well, this is completely misinterpreting what we're given. This is implying growth over time, which would look like a subtraction problem between two different weeks, not like a static point evaluation like we're given. This is just completely wrong compared to A and C. C would be our correct answer. A flips the information. B is just not what this equation means. Okay, last problem. This will probably be the hardest problem you'll see if it's on your quiz. So let's just get through it real quick. Number 6. For c of x is equal to x squared plus 8, solve for k such that 4 times c of k is equal to c of 4k. So we are given this function, right, and we're asked to solve for k such that these are equivalent. And what I'm testing you with this problem is whether you truly understand the difference between putting a number outside of the function versus inside the parentheses as an input. I think it will be helpful to tackle these two different, the left hand side and the right hand side differently to really see the difference. Because there's a reason why I put 4 as both of the numbers. So let's look at the left hand side. The left hand side of the equation states 4 times c of k. What this is telling us to do is it's telling us to plug in k for our c function and then multiply it by 4. So this will be equal to 4 times c of k, which is k squared plus 8. Now we need to distribute our 4, so we'll end up with 4 k squared plus, and then 8 times 4 is 32. That's the left-hand side. Now for the right-hand side, c of 4k. Now, I have a question for you. I want you to think about this. Well, c of 4k, we're plugging in 4k for x and c of x. Will this be equal to 4k squared plus 8 or 4k squared, quantity squared, plus 8? In terms of this problem, this first equation would be incorrect because we are asked to plug in 4k as a quantity, not just k. What this is telling us is this is just telling us to square k, not 4 as well. If we're given an input, it's very important to plug in everything that is telling us to, not just k. So therefore, this bottom equation would be correct. Because what we're going to do now is we're going to square 4 and k. So 4 squared is 16. So 16k squared plus 8 is what we'd be left with for c of 4k. Okay. And now we can set both of these two simplified sides equal to each other and solve for k. So we'll end up with 4k squared plus 32 is equal to 16k squared plus 8. Let's subtract 4k squared from both sides to keep our variable terms positive. So 32 is equal to 12k squared plus 8. And then subtract 8 from both sides. 32 minus 8 is 24. 24 is equal to 12k squared. And we're going to divide by 12. So 2 is equal to k squared. K squared is equal to 2. I like putting the variable on the left because saying k is equal to some number over some number is equal to k helps my brain see that better. Okay, and remember, last step, we have to take the square root of both sides. But remember, whenever we introduce a square root to solve an equation, we have to put the positive and the negative version of the number. I'm going to rewrite that k. So therefore, k is equal to plus or minus the square root of 2. And if you really wanted to get fancy with your solution, you could have written it in set notation, open curly bracket, plus or minus root 2, close curly bracket. And that's how I write it on my key. Both are perfectly acceptable. And yep, that'll be it for version A for my concept check 1 over functions. If you want more practice like this, go check out versions B and C. The answer keys are also provided for extra practice. But yep, that'll be it. Thank y'all for watching.